Okay, so yes, ma'am. Number one. So did you read up above? Okay. Okay. Oh, what did the back of the book say, first of all? 03? Okay. So it says the object to be photographed is 10 feet away. So where is that going to go? Because it needs to be, yeah, it was the distance between the lens and the object. So you put 1/10 there. And they told you what f was, didn't they? It was 2. So you had 1/2 should have equals 1 over d sub I guess, plus 1/10. Okay, and it says how far should the lens be? Okay, so did anybody, how did you go about solving this? What did you do? Oh, thank you. Yeah, that's the problem. So yeah, so we should probably change that feet into inches and make that 10 feet into, yeah, thank you, 120. See if that helps. Yeah, it changed to pink. Do you want to try it from there then? Okay, good. Okay, what else? Yes. Number 40. Okay, this was a subtraction problem. And whenever we do any of these, addition or subtraction, the first thing you always want to do is what with all of your denominators? Okay, and to get them equal, how are you going to get them equal? What are we going to have to do? Yes, so let's go through and factor our denominators. So 2y minus 14 plus 9 over y. So I'm going to go ahead and factor them just right below what we see right here. So y squared minus 7y is going to factor into, good. 2y minus 14 factors into, very nice. And then, of course, we just have y. Then usually what I like to do is off to the side, I just like to identify my least common denominator. And I think the easiest way is just to start with the very first denominator and write down the factors, y times y minus 7. And then you just go across to each one and you write down any missing factors. So from this one, do you see a factor of a 2 in your LCD? Over here? Nope, so let's put one there. Do you see a factor of a y minus 7 over here? Yep, so I don't need to write it because it's already there. Does that make sense? Okay, so now we come to this one. Do you see a factor of a y over here in your LCD? Yeah, so I don't need to write it. So I've got all the necessary factors that I need. Now, go to each fraction and multiply by any of the missing factors. So that first fraction, it's got a y and a y minus 7. Is it missing any of the factors from the LCD? It's missing a 2, so multiply top and bottom by a 2. Okay? What about this one? Is it missing any of the factors from over there? A y, so multiply numerator and denominator by a y. And finally, this last one, is it missing anything? A 2 and a y minus 7. Okay, so let's clean up the numerators. So on top we have 10y over, now, here's a little trick that I'm okay with. As long as you've written LCD and told me what it equals, if you want to right here write LCD instead of writing it all out, that's fine. But you have to somewhere tell me what that LCD is. Okay? Then we're going to have minus 4y over the LCD plus, and here we're going to end up with 18 times that quantity. So let's go ahead and distribute, and it would be 18y minus 126, okay, all over the LCD. So now they all have the same LCD, so we can write it all as one. It's 10y minus 4y plus 18y minus 126 all over the LCD. So go ahead and add and subtract, combine like terms, and you're going to end up with what, 24y? Okay, all over the LCD of 2y times y minus 7. Now there's one last step that we're supposed to remember to do, and that is see if we can factor and reduce. The denominator should always already be factored. So it's only the numerator you have to worry about factoring. And can you factor the numerator at all? Yes, what can you factor? You can pull out a 6. So you're going to have 6 times 4y minus 21 over 2y times y minus 7. And can anything reduce? Shelby? Yeah, the 2 and the 6 here. So you end up with 3 times the quantity 4y minus 21 over y times the quantity y minus 7. Okay? Does that help with that one? Question on this one? Yes?
In my, I didn't factor the quantity, so I just, all my denominators would go to y squared.
That's fine. The only drawback to that is that sometimes things get really big when you multiply. You're going to have big exponents. You're going to have things that you're going to have polynomials that may have several terms and may be difficult to factor. Okay? That won't always happen, but sometimes it will. That's why I like to factor first, because then you've got the least common denominator. You have a common denominator, you just don't have the least common denominator. It's not wrong. Okay?
The fourth step, like the middle step, I think.
Yes. Right here? Yes?
I divided it by 2 and divided the bottom by 2.
That's fine. That's essentially reducing as well. Okay? And that's all I did when I factored out here. So you probably had 12y minus 63. Yeah, which is fine, because even if you factor it, nothing else reduces. So as long as you're certain nothing else is going to reduce, that's fine. Okay? Good. Any other questions on this one? Okay. Yes? Yes, yes. You don't have to factor it. However, if you don't factor it and you miss reducing because of it, then you might lose some credit. Okay? Does that make sense? So, okay, good. And then I saw some other hands. Trey. Number 37. 5x squared plus 6x plus 12 over x minus 3, the quantity, times the quantity x plus 2, that quantity squared. So you can either have x plus 2, the quantity squared, or an x plus 2 times an x plus 2. The numerator is 5x squared plus 6x plus 12. Does it say that again? No, it doesn't matter the order. Zach? Negative 3 times the quantity 2y plus 1, or if you had negative 6y minus 3 on top, that's fine. And then it's all over 2y minus 1. Yep. You make sure that on the numerator you distribute that negative sign before the second polynomial. So it should be, they already have a common denominator, don't they? Right? Do you see that they have a common denominator? So you can go ahead and combine the numerators, and when you do, it's negative 5y minus the quantity y plus 3 all over that common denominator of 2y minus 1. So you have to distribute that negative sign. So negative 5y minus y. Did I copy something down wrong? No, that's right. So negative 5y minus y is negative 6y minus 3 over 2y minus 1. And then if you factor out the negative 3, you end up with a positive 2y and a positive 1. Okay? Be careful of negative signs. Okay, what time do we get out of here today? 16. Okay, I need to show you one other thing. Otherwise, you're going to be lost on your assignment. You're going to do more of these tonight. The other thing that I also want to show you is something called complex fractions. And a complex fraction is basically just fractions inside of fractions. So if you have fractions inside of fractions, they're complex. So I've just shown you some, like 1 over x over y is a complex fraction. And this one, do you see how you have a little fraction inside the big fraction? Okay. These are all what we call complex fractions. Yes? Possibly, because that would be a complex fraction. Okay? Now, we're going to look at simplifying these complex fractions, and there's more than one way to go about it. So let me just put up one that we can simplify, and we'll try to simplify a couple of these. So let's try this one. We won't start too difficult. 1 over x plus 3 all over 5 over y plus 4. Now, there are really two ways to go about this. One is using things that you probably already know. And that would be, in order to put these two together, 1 over x plus 3, what would you have to have? Yes, so if you just looked at the numerator, you'd have 1 over x plus 3 over 1. And to get a common denominator there, you would just do what? Multiply this by an x, right? So in the numerator, you would end up with 1 plus 3x divided by x. Do you agree? Okay. Then in the denominator, couldn't you do the same thing? That 4 would have to become what? 4y over y, right? Multiply top and bottom by 4 by y. So now that these two have a common denominator, do you agree? And so now in the denominator, you would have 5 plus 4y all over y. Whoa. I wish I had a little eraser. Okay. 5 plus 4y over y. Okay. Do you agree with what I've done so far? Now, the reason I wanted to get a single fraction in the top and a single fraction in the bottom is because you should know that if you take a fraction divided by a fraction, how can you work with that? Multiplied by the reciprocal, right? We just did that a couple of days ago. So what this turns into is 1 plus 3x over x times, this is going to become, there you go. And if you multiply numerators and then multiply denominators, you end up with y times 1 plus 3x, that quantity, over x times the quantity 5 plus 4y. No longer do we have fractions inside of fractions. You see how I did that? Now, this uses nothing new, really. This uses all stuff that you already know. There's another way to do this, which I personally think is easier. And I'm going to show it to you. So, same problem. What I want you to do is I want you to find the LCD of all the little fractions. Find LCD of the little fractions. Well, what's the LCD of all the little fractions? It's just xy, isn't it? Because there are just two little fractions. So the LCD in this one is x times y. Does everybody see that? Okay. Then I want you to multiply the numerator and denominator of the large fraction by the LCD. Be sure that you distribute. Put an xy up here and an xy down here. and distribute. If you take 1 over x times xy, that would give you xy over x. Do you agree? But xy over x is just y. It gets rid of the fraction for you. Then distribute. Plus 3xy. Right? Over. Do the same thing in the denominator. That's going to give you 5x plus 4xy. Then the last step is see if you can factor and reduce. Well, in the top, what can you pull out? That has a common factor of a y, and you get 1 plus 3x. What about the denominator? There's an x, and that's going to leave you with 5 plus 4y. Can anything reduce? No. Is it any different than the last answer? No. Okay? Bless you. I personally like the second method. I think it's easier once you get the hang of it. Now, do I care which method you use? Not really, but I'm going to be doing it using this method up on the board. Okay? I think this is a faster method, and I think it's very valuable for you to learn. Okay. For tonight, you're going to try some more adding and subtracting, and then have some of these complex fractions. And tomorrow, we will go over those.